Jumping is one of the most fundamental mechanics in platformer games, and understanding how it has evolved shows a lot about game design. Today I will focus on jump physics, how characters move in the air, how jumps are calculated, and how players interact with these mechanics. We will explore this evolution through three keys games: Super Mario Bros. 1985, Super Mario 64 1996, Celeste 2018. Each game represents a different era in 2D and 3D platformers and shows how jump physics change the player experience. In Super Mario Bros., jumping is little but carefully designed. The jump height is determined by how long you hold the jump button. Horizontal movement in mid-air is limited. This reflects the 2D jump physics of the 8-bit era, fixed acceleration and gravity values, no momentum-based tricks. For players, this meant timing was crucial. You had to anticipate obstacles and control the distance precisely. Even with its simplicity, the jump felt satisfying and responsive, demonstrating the importance of basic jump physics in early platformers. Additionally, these jumps allowed for subtle skill expression. For example, players could perform short hops to avoid enemies or long jumps to cross wide gaps. The predictable physics encourage experimentation, and mastering the exact timing of jumps directly affected success in each level. This careful balance between simplicity and challenge is what made Super Mario Bros. Iconic and helped define the standard for all future performers. Super Mario 64 1996 early 3D jumps physics. With Super Mario 64, jumping entered the 3D world and jump physics became more complex. Mario could perform backflips, triple jumps, long jumps, and wall kicks. The analog sticks allowed variable speed direction affecting both horizontal and vertical movement in mid-air. Here jump physics included momentum, gravity, and collision detection in 3D space. This gave players much more freedom of experiment. You could change jumps, bounce off walls, or reach hidden areas. Jumping was no longer just survival, it became a tool for exploration and creative problem solving, showing how physics in 3D dramatically expanded platforming possibilities. The addition of precise 3D jump physics also introduced a new layer of skill mastery. Players had to learn how momentum carried Mario across platforms, how wall jumps could be angled to reach secret spots, how timing affected each jump's trajectory. They made the game feel alive, interactive, turning movement itself into an engaging puzzle. By allowing freedom in midair, Super Mario 64 transferred the jump from a simple action into a core part of player expression and gameplay strategy. Furthermore, the game's level design was built around these advanced jump mechanics. Each level encouraged experimentation, rewarding players who explored different ways to change jumps and navigate obstacles, hidden stars. And now Celeste 2018 Modern Precision Jump Physics. Celeste demonstrates modern precision jump physics. Maddy can jump, dash in mid-air, and climbs walls. Each movement is calculated with exact acceleration, momentum, and collision mechanics to allow precise player control. Dash mechanics interact with jumps, enabling complex movement like chaining wall climbs into mid-air dashes. This requires the player to master timing and physics to navigate tight spaces. Modern platformers like Celeste show how jump physics can be designed not just for fun, but also for challenge, skill, and expression. So at the end, in conclusion, I will say that looking at these three games, we can see the evolution of jump physics from simple variable to height jumps in 2D to momentum-based 3D jumps to highly precise and expressive movement in modern platformers. Jump physics may seem basic, but it shapes player experience, creativity, and the very feel of the game. The evolution of jumps in platformers reflect decades of design, even innovation, keeping players engaged across generations.